to my CPU squad. This is a Fix Engine update. Just want to give you guys a quick update. First of all, thank you very much for the help from absolutely Nick and Mr. Lunar. I'm gonna call you Mr. Lunar. Mr. Lunar, great work with the translation code. Looks pretty good, and that was pretty much the final piece required for us to move forward. So here's where we're at right now. I am ready to move to the final phase of this initial phase of this project. Really, what we've been doing is really exploratory. You could kind of consider it R&D, research and development, where whoa, I'm not even public. Let's make this stream public so people can see it. So it's been let's explore the types of technology, techniques, and logic that's going to be required to build what we're trying to build, right? You don't just jump in and like, hey, I'm going to build a Fix Engine, right? You gotta understand what it is that you're trying to build, which is why I did the presentation. I might need to do an extract from that to make it more concise and to the point, but that's why I did the presentation where I went over the overview of how the technology works, where you got a front-end application which is connected to a database, which is connected to a Fix Engine or Fix server, which is going to send these electronic messages to an outside source, whoever you're trading with, and so on and so forth, the back and forth between that, the writing of the fixed messages to a flat file, the fixed log, and at the same time writing to a database. So simultaneous inserts to a database with writes to a log file, right? So went over the basic flow, and then also the basic techniques. What types of things are we going to need to do in Python to make this work? We've got to be able to, well, for research purposes, we need to be able to insert, well, not just research actually, because the OMS we need the same feature, but the inserting an alphanumeric string was I guess hybrid. It was half for research and half for the actual final product. For research, it was allowed us an easy way that we could insert fixed messages without actually having an actual fix engine and an actual source to fix messages. You could just free form, just type things into the to the program, and there you go, good to go. But long term, we're going to need that for the OMS. Now, the fix engine itself, we're not going to be manually inserting messages in there. Of course, that's not the way it works. But for the OMS, the user is going to need to be able to enter order information. 100 shares, IBM, this price, all that kind of stuff. So we do need to basically figure out that part of the logic, which we did fundamentally, right? We got to go deeper than where we went. But the thing is to just get in the zone, right? Get in the basic zone, understand the fundamentals, and then from there you have sort of a launch point where you can get into the deep dive, which is coming, right, to actually build the final product. So we did that. Then there was the parsing. We got to parse between being able to generate SQL queries from fixed messages. So going from fix to SQL and SQL to fix, for example. That's something we need to be able to do. One thing that we did not do, which, wow, actually, I should add this. I already built this, so this will be a quick thing, but logging, as I mentioned, one of the things that a fix engine does is generate a log, a actual fix log. And, I'm not talking about a traditional log. There will be a traditional log as well. A typical model would be where there'll be a application log type of deal where, let's say, application level problems. There's a memory issue, CPU issue, bad code. It freezes up, anything like that. There's that log. But then the fix log itself is actually the heart of what we're building, right? You're transmitting electronically financial information. orders, executions, prices, symbols, right? That's the meat of this whole thing, right? So that fixed log pretty much consists of the orders and executions that the traders have created and have manipulated in the fixed format, right? So that's the actual transactions in a text, human readable format, right? Tag equals value format, right? So that needs to be written. So the product needs to write to a log file, and then we need to also convert from fixed to SQL and SQL to fix. So number one, I need to add logging, generate that flat file, the fixed log. And since and that will complete all of the requirements for the initial phase, the exploratory phase. So that'll move us to the next phase, which will be to integrate, go modular, right? So pretty much create a single Python script that will utilize all the stuff we've built, call it from one single file. So I don't know if this would be considered, I don't know if I'm using the correct lingo here, if it would be considered a class file, because when I think of a class file, I think of literal classes, right? So you would import that, and then you'd actually be able to, I think it's instantiate is the correct term, the object. But that's interesting. I think we're gonna need to be at some point. Yeah, I think classes is something that we're probably going to end up using for the final product. I gotta think more about that, but the initial thought that comes to mind is that message types are classes, right? I'm gonna leave it at that, but let's just say message types are classes. So an order consists of certain elements, right? An execution consists of certain elements. So I think that's kind of where we're headed. But specifically for what I'm trying to do now, I don't think maybe class file is not the word, because what I'm talking about specifically would be, and I got to look through the code, but I think basically what we've done, a lot of what we've done is functions, or at least it can all be contained in functions. So what we're talking about doing is having a file with some functions, separate files with different functions that we're going to import into another file. So we built like 6 different Python files, so I would need to make them be in a format where they can be imported into another file. And from what I understand, from what I recall, I believe the only thing we can import are classes and functions. I might be wrong about that, but that's my understanding. That's the stuff I need to figure out. So build logging, at least ponder classes and how it might or might not apply to the final product, because depending on that thought process, I might need to add another feature. So we might need 2 more features, logging and classes. So like an order class, execution class. But I think perhaps what I will do before I do that is do what I neglected to do before, which is take R&D to the next level. Go back through the quick fix libraries and see what's in there, right? If we're going to use quick fix to build what we're building, we need to understand what is quick fix in terms of What is the extent of those libraries? What are they capable of doing? Because I look at it as a puzzle. We're trying to build, or we're trying to piece together a puzzle. The final puzzle consists of a functioning OMS, a network and database capable, FIX compliant OMS or order entry system, which is connected to a functional network capable and FIX compliant, obviously FIX engine, that are able to communicate and exchange information with another pair of products, right, that are the same. So we would need two sets of order entry and FIX engines, right? So we have one order entry system and one FIX engine, which connects to another FIX engine and another order entry system behind that. Now, to be clear, in reality, the products could actually be different from different vendors. But in this situation, we don't need to do that, obviously. We can build one FIX engine, one OMS, right? And then we just have two instances of each, right? So we have one FIX engine that we connect to another FIX engine over the network. And then we have both of those FIX engines connected to a database and a front-end application. And I got to work through how that's going to work in terms of connectivity. Because if we're doing this over the network, I mean, what am I saying? Why can't? Of course you can connect. I mean, the way that a real product would work is you wouldn't be in the same network, but that's not a problem. There's no reason that you can't have two FIX engines in the same network. It's just that wouldn't make any sense. The whole point of FIX is to be able to communicate with someone else. But for the purpose of this project, that's irrelevant. Now, it would be really cool if at some point in time when we build this thing that I could actually establish a connection between my engine and one of you guys. So you guys could launch the product on your side and see if we could actually establish a connection over the internet and actually run some tests. That would be super awesome, but that's a whole nother story. But first thing first, there would need to be two processes. Now we're talking about networking, so that means I would need obviously two physical computers. So I could run my OMS and FIX engine and database on my desktop, and then I could run another set of apps on a laptop or something, connect the engines over my home network, and then do the whole deal like that. But anyway, add logging, consider class files for order types, execution types. And actually before that, I'm going to look through the libraries, because again, we're building a puzzle, and in order to complete the puzzle, we need to understand or take an inventory of what pieces we already have, right? So I need to know what is the full extent of what these libraries can do. What can we do? What is all that we can do with the quick fix libraries? By knowing that, I can know what we need to build to augment and to complete the picture that we are trying to paint, right? So going through the quick fix libraries, then do the logging. Think about the class files. If I determine that that's something that needs to be built, I will build that. That'll be the final piece. And then we can move on to integration of all the scripts from separate files. And then that'll be phase 1 complete. Then that's where the real fun begins. Phase 2, I think it would be advisable because we don't have a full team of developers. None of us have ever built this before, or even a similar thing before. So I think for phase 2, what we should do is build the simulator, right? That way we can get through the motions of the logic and how this thing works, and we can iron out any disconnect between what I'm describing to you guys and your interpretation of what I'm describing to you guys, right? Because I'm in my head visualizing a certain thing, and I'm trying to communicate as best I can to you guys. You guys are trying your best to understand and interpret what I'm saying to you, and the end result would be the net result of that in terms of the deviation between what I'm communicating to you guys and what your interpretation of it is. Right, so it's not going to be probably very unlikely to be exact. So once we actually have something to look at and I can say, no guys, this is not what I meant, then we can get closer in alignment to how this thing is supposed to work and what we're actually building. So at that point in time, we would have had the experience of all of the fundamental knowledge that's required in logic, and would have a much clearer picture of how this whole thing's supposed to work. And then at that point in time, we could actually move to phase 3, which is to actually build some form of actual product. Extremely limited in functionality initially, just to get it done. And then once we build that successfully and we're like, we can be proud and like, wow, we did this, then we can just start feature by feature expanding. And I would think rather than just randomly doing that, I think just like how I'm gonna set a really dumbed down super basic feature set to start for the simulator and the first version of the product, I'm gonna create a second generation feature set that's still simple but more practical. Like instead of just being able to do 1 or 2 things, we'll be able to do a series of things. Not as extensive as a typical fixed engine would be, but still, you know, something more practical than the first generation will be. So instead of like just being able to enter an order and acknowledge an order, and then maybe fill an order, very simple, we'll be able to do connection logic, sequence number tracking, cancel places where you can modify an order. You can pull in market data. You know, there's a lot of stuff. Maybe even build a basic algo. Right? Algo can get crazy, but we could at least explore some basics. You know, if price increases by a certain percentage in a certain period of time, then do this. You know what I mean? Like, that's like super simple. Anyway, that's where we're at. So without further ado, I'm gonna get to it and do my dive into the quick fix libraries. So this is the CPU Squad, and I will
will see you guys shortly. CPU Squad. All right, guys. Thanks for listening in, and stay tuned.